So for this part of the tutorial, we're going to cover several ways of programming the GPIO pins on the Raspberry Pi. But before I do that, I want to introduce you to a new product. This is the Raspberry Pi LED indicator board, or RPi-LED for short. And this board is really neat because you don't have to figure out your own resistor values or calculate anything to run the LEDs. If you just want to jump right into programming, you can get this RPi-LED board, and it plugs directly into the 40-pin header on the Raspberry Pi. Especially if you're a new programmer and you just want to play, get this in and write some code, and you're turning LEDs on and off. And not only that, there is a neat little light show that you can download the source code for free. I have a link down below. It also has some details about the board itself and some specifications. But you can get this LED light show, and it looks like this. So let's get down now to the tutorial. So what we're going to do is we're first going to cover using Python. Now, I don't know how many folks know this. The Pi in Raspberry Pi stands for Python interpreter. So it makes sense that we use Python as our first example. So I'm going to go through some examples of how to set and clear some of the port pins on the Raspberry Pi. I'm going to be using the RPi-LED board as a visual aid so you can see the pins turning on and off. Then we're going to cover how to do it in the command line. Now, if you want to learn more about programming the port pins using C code, then I would suggest going to the link below, go to the RPi-LED page, download the free source code, and that's all written in C, and it will show you how to use character device drivers, basically using a built-in device driver in the Linux operating system on the Raspberry Pi. It's not specific to the Raspberry Pi, so it works on many single board computers as long as those single board computers support character device drivers. So it's a way to actually open a driver and talk to the GPIO pins through an actual driver, which is the normal way that most people will access hardware on any system that runs Linux or some type of operating system on it. Okay, so let's get started. So before I start to write the Python program for our demonstration, I want to create a directory. So I'm in my Pi directory, pwd, so I'm in home Pi directory, and I want to create a directory, a subdirectory to work out of. So I'm going to say mkdir python, all lowercase, and then I'm going to change into that directory. And if I do a listing, of course there's nothing there yet. So what I want to do is I want to create the program. So I'm going to type, now I don't have to do sudo or be super user because I'm in the home directory where I don't need permissions to do that. So I'm just going to type in nano, and I'm going to call my program led.py. Hit enter. So the first line that we need to enter in here is a command to the Bash shell that basically tells it what program to run our script. So we wanted to tell it to run Python. So we're going to type in $, exclamation point, user, and this is specific to this particular OS I'm running. Your Python could be in a different spot if you're running a different OS, in which case you'd have to put the path to where your Python is located. Okay, now I need to import the modules that already have some code that I need to use. So and this is case sensitive, so make sure you get the case right. So RPi.GPIO, and I don't want to have to type RPi dot before each GPIO command that I'm going to use. So I'm going to say as GPIO, so I can just say GPIO. Then I want to import time for the delays for blinking the LED. Okay, so first thing I'm going to do is define the pins or the numbers of the pins that I want to use. Now you can make this text anything you want. I'm going to try to make them descriptive for what I'm doing. So let me put a little comment here. Find GPIO pin numbers, and I'm going to say GPIO 21, and that is on the header, pin 40, and that's equal to BCM number 21, which of course matches with GPIO 21. Then I'm going to say I'm going to do 3 pins, I think, for this example. So let's do pin 20 right next to 21. GPIO 21, and that's on pin 38 on the header, and of course that's equal to BMI 20. Then the last one, GPIO 16, which is right next to the other two, and that'll be pin 36. Of course, that will be BCM 16 or GPIO 16. Okay, so next, I need to set this up to work in BCM mode so that these numbers match the port pins and everything that I'm using. So here, we'll just do, I want to use GPIO, oops, reference numbers. Okay, so to do that, we say GPIO dot set mode to GPIO dot BCM. Okay, that sets our mode. Now let's set up our 3 pins as outputs. So let's type setup GPIO outputs for my 3 pins. Okay, this will be GPIO dot setup, and I need to type my first definition there. I could just put 21 here, but I'm going to put the definition because it helps the code to make more sense, makes it more readable. GPIO 21 underscore pin 40, and that will be GPIO, setting this up as an output. Okay, the next one is the same thing. That'll be GPIO 20 underscore 38. This will also be GPIO.out. And the last one, GPIO 16 on pin 36, and that'll be GPIO.out. Okay, so all 3 pins are now set as outputs, and before we actually do anything with the pins, let me just do a little print statement. And we'll say, let's do a carriage return, and we'll say start of GPIO program. Okay, there we go. Now we want to, I want to flash the LED 20 times. So I repeat 20 times. So to do this, we need to define a variable here. So we're going to say for, let's say loop. For loop in range 20, semicolon, or no, colon. Then we need to hit a tab for our next entry, and this is going to be GPIO.output. Because now we want to set the output. And again, we want to use the same definition. I could put 21 here, but I already defined the pin, which is descriptive, so I'll call it GPIO 21 underscore pin 40. And I'm going to say comma, and I want to say GPIO.high. This will set that pin high. So I need to repeat that for the next 2 pins. And the last one. Okay, so that sets all 3 port pins high, but now I want to keep them on for a little bit of time. So let's just let's take a break. Well, in the code. Take a break. Have a coffee. For 200 milliseconds. Well, that's a very short coffee break. Now we want to set the pins low. So we're going to use the same command as above, GPIO.output, and same pin definitions, GPIO 21, score pin 40, GPIO.O. And we want to repeat this for the following, the next 2 pins as well. And the last pin, GPIO.output. GPIO, and this is last one 16 underscore pin 36. Okay, so now we set the pins. Wait, whoa, we have to back up. I did not put the time statement. I don't think that the comment is going to cause a delay. We need to actually type in here. We need to put time.sleep 0.2 for 20 milliseconds. Wow, if we would have missed that, we would not have seen any change in the LEDs because it would have been so quick. Okay, so now that we set them high, we took a break for 200 milliseconds. Now we set them low. We don't want to loop back around and set them high again, or we'll never see them go low, so therefore we need another break. Sleep 0.2. There we go, another 200 milliseconds. So that finishes the flashing of our LEDs. Now we need to do some cleanup. So we say GPIO.cleanup. And let's put an exit message. So print, we'll say finished, so carriage return. And we'll say finished flashing. Finish flashing LEDs on the RPi-LED board. Oops. And there we go. So I will leave this up for a few seconds to allow everybody to have a chance to look at it or pause. Hopefully I haven't made any mistakes. We're going to have to come back and edit again, so we'll see. Let's typing this in pretty quickly for the example. So now, since I'm in Nano, I need to save this. I'm going to say Control-O. The file name comes up. I'm going to hit Enter. Okay, just saved it. And I'm going to exit the Nano editor. Okay. So let's do a listing, ls-als. There we go. So we have LED-py. But notice it's grayed out. It is not executable, so we can't run the program. So we need to type in chmod plus x led.py. Now if we do a listing, ls-als, we can see it's executable. So let's give this a try. /led.py. Will it run? Let's see. And it did. Notice it's flashing. Here's the 3 LEDs. They'll flash 20 times, and the program exited, and we just finished. So now we are ready to move on to our next example, and this one will be a little bit shorter. This is just how to quickly set the LEDs, set the GPIO outputs to turn on off the LEDs from the command line. So for that, we're going to use a third-party tool or a third-party program called GPIO. So to do that, we will type in, first we have to set the mode of the pins. So we're going to say GPIO-G mode, and I want to use BCM21, which is on pin 40 as we used before, 21, and I want to set that as an output. So this sets the mode of the pin just like we did in the Python program. Then I'll do the next pin. I'll light the same 3 pins. So GPIO-G and BCM20, mode, BCM20 as an output. Then GPIO-G mode, and we'll do 16 as an output, just like we did before. Now we're ready to turn the pins on. So first pin, GPIO-G, write to BCM21 and write a 1. This should turn it on. And there we go. First one is on. Now the second pin, GPIO-G, write, and this will be pin BCM20, and set that to a 1. Boom, there we go. And then the last pin, GPIO-G, write, and this will be 16. Same pins we used before, and they are all on. So then if you want to turn them back off, you do the same thing, except you just set it to a 0. So GPIO-G, write 16 for BCM16, and set it to a 0, and it turned it off. So this concludes our Fun with Raspberry Pi tutorial. We hope you enjoyed this video.